Okay, so we're going to take a look here at section 2.3. And we're going to break section 2.3 into about 4 different sections here, going through and solving these trig equations. Ultimately, we're going to end up combining about 4 or 5 skills that you've been using this year and you've used throughout the years that you've been doing some linear algebra solving equation type things. The first skill that we're going to use is the idea of the triangles that we've kind of just been working on. So if I have a sine equal to 1/2, the sign is positive, and so what I end up doing is I end up knowing that the sign is actually a y value, and so that y value is going to make two different triangles in the positive direction. I don't know which one. Before, we had an extra piece of information when we were finding the 6 trig functions that told us which one of those two triangles we were using. And the fact is that I don't need to know which one. I actually need to know both of them. And this is the reason why I need to know both of them, is that I'm looking for an angle that's between 0 and 360, that when I take the sine of that angle, I get 1/2. Now we can go to our unit circle and do this, but I kind of want to use one that's a nice number, and so that's why we're using 1/2 here. But we want to go through and we want to solve this equation. Okay, so I'm solving this equation, and if you remember, what I'm solving for is this reference angle right here. Okay, so I have these two triangles, and I'm looking for the reference angle. Now, when I go through and solve this, I'm taking sine inverse of sine theta and sine inverse of 1/2. So the sines are going to cancel over here. What I want to know is what is theta. And so I plug sine inverse 1/2 into my calculator, or if you already know it from the unit circle, or if you remember it from any of the other times that we've really kind of talked about it, you end up that we have a 30-degree angle here. Now, again, make sure that your calculator is in degrees, because everything that we're going to be looking at here is going to be in degrees. So what I ended up finding is actually a reference angle. Okay, so the reference angle is 30 degrees. So when I plug that into my picture here, I get a 30-degree angle here. But ultimately the question is, what are the degree measurements that I can plug in there? Well, the one of them is 30 degrees. This angle right here is 30 degrees. But I also want the one that goes this way. I want the one that continues all the way across here, because I could also plug in that angle to get a sine of 1/2. And so I've got one of my angles is this angle, because it's in the first quadrant, and you'll see as we go along what maybe this portion of it will make a little bit more sense. But the angle in green is actually 180 minus 30, which is 150 degrees. So if I took on my calculator, if I did sine of 150 degrees, I should also get an angle of an answer of 1/2. And you can go ahead and check that on your calculator. So I end up with theta is equal to 30 degrees and theta is equal to 150 degrees. Okay, I can plug in both of those two numbers in order to get a 1/2 when I take the sine of it. Let's try another one. Another nice easy one with the tangent here. We've got tangent is negative. And so the tangent, if the tangent is negative, that again you can refer to the chapter 2 worksheet that we had for the resource sheet. But ultimately, I'm taking a negative y over a positive x, which ends up getting me down in this quadrant down here, a negative y over a positive x, or I'm taking a negative x and a positive y. So these are my two angles, and this is the reference angle that I'm going to find by solving this equation. So I'm going to take the inverse tangent to both sides. Inverse tangent is going to cancel out, and I'm going to take the inverse tangent of negative 3/4, which gives me a negative 36.87. Everything we round is going to be rounded to the hundredths. Okay, now remember again, that is a reference angle. Okay, so it's a reference angle. So when I look at this, the angle that I'm getting is here from my calculator, negative 36.87, going in the negative direction, 36.87 degrees. The reference angle, remember, is the absolute value of that. So I end up with a, I didn't mean to draw that through the negative, but I end up with a positive 36.87 here. Now, that 36.87 degrees is not my answer. My answer is going to come from finding out what this angle is right here and what this angle is. It goes all the way around and stops there. Okay, and so the angle in blue I can find by doing the same exact thing that I did before. Take the 180 degrees minus 32.87, which gives me 143.13 degrees. So that's one of my answers. And then the one in red, the one in red is 360 degrees all the way around, but I'm missing this little tiny part that's in green. So I'm taking 360 minus the 36.87. Then I'm getting the angle in red is 323.13 degrees. Okay, so when I go through, I end up, let's put that down here, 360 minus the 36.87. Okay, so when I go through, what I'm looking for is the angle that I can plug in. Yes, I could plug in a negative 36.87, but I want my angles to be between 0 and 360 degrees, which means that if you have a negative one, you're not looking for the negative one. You have to turn that into a coterminal angle by adding 360 or subtracting 360, depending on how you end up with that picture. So that's the basic idea behind this section. Now, some things that are going to come back, this is again going to be kind of combining a bunch of skills. So that skill is a little bit new, but we've been finding portions of triangles, doing inverse trig functions. This is a skill that's going to be coming back. So I hope that you remember that this is how you solve linear equations. Okay. Skills like this, using the distributive property if you have a distributive property problem. Then add 6 to both sides, 5x equals 2x. The 6's actually are going to cancel. Subtract 2x. When I subtract 2x from the right-hand side, I actually get a 0, so don't forget that actually happens. Whoops, this is 3x. Divide by 3. And it's okay to get answers of zeros. I just want to remind you some linear function ideas. Because when we come to a problem like this, that's what we're going to do. The goal is to get the theta by itself. So I need to solve the equation first. So I'm going to add 1 to both sides. So I get 2 sine theta is equal to negative 1. Divide by 2. Sine theta equals negative 1/2. I want to get the theta by itself, so I need to do the inverse sine to get rid of the sine. So the sine is going to cancel out. I'm going to get theta equals the sine inverse of negative 1/2, which is negative 30 degrees. Again, I want to be drawing this triangle, so the place that I want to look for my triangle is that the sine is negative. And so the place that the sine is negative, it is down here where the y value is negative. So I end up with 2 triangles down here. I get a reference angle. A reference angle of negative 30. So this is 30 degrees here, and this one is 30 degrees here. the first angle that I get to is this one, and so I went 180 degrees and I added another 30. So my angle in green is 180 plus 30 degrees is equal to 210 degrees. And my angle that's going to be in red here in a second, going all the way around the circle this way, is 360 degrees minus that 30 degrees, which is 330 degrees. Okay, and those are my two angles based on the equation that I had. This is number one on your worksheet, by the way, as well. When I go to the last example here, I've got a similar problem to the distributive property problem that I had. This problem on your worksheet is actually number 18. So this is number 18 on your worksheet. I have a distributive property here. So I've got 5 tangent theta minus 6 is equal to 2 tangent theta minus 6. I'm going to add 6 to both sides. Hopefully this is ringing a bell. We just did a problem like this with the linear idea. The 6's are all going to cancel out. I have 5 tangent theta and 2 tangent theta, so I'm going to subtract 2 tangent thetas. Treat that trig function, 2 tangent theta. Treat that trig function like a variable, so 2 tangent theta minus 2 tangent theta is 0. 5 tangent theta minus 2 tangent theta is 3 tangent theta. Let me slow down a little bit. Divide by 3, and I get tangent theta is equal to 0. Okay, well, now this is a little bit more tricky. We need to think about where tangent is equal to 0. That's the y value divided by the x value. So that means that I had y is equal to 0 and x is equal to 1. So what ends up happening is that I'm actually on the x-axis here, on the x-axis, because I didn't go anywhere up and down, but I went to the left and right. So I actually have the point right here. And so when I solve this problem, when I do tangent inverse of tangent theta and tangent inverse of 0, I get the reference angle, or the answer that the calculator is going to give us is going to be 0. Okay, but I also need to know that tangent is also 0 at 180, because I didn't go up and down at all. And if I divide by a -1, I still get an answer of 0. And so then this theta is also equal to 180 degrees. So I get 0 degrees and 180 degrees. That's an example of one that falls on the x-axis. I'm going to do one more here that goes along with a little bit of solving and makes another triangle too. Here's the problem. It's number 19. I'm going to go through and do the distributive property here. So I get 7 minus secant theta equals 2 secant theta plus 2. I treat these like secants like variables, so a lot of you want to deal with the secants first, so go ahead and do that. I get 7 equals 3 secant theta now, plus 2. Subtract 2 from both sides. 5 is equal to 3 secant theta. Divide by 3. And secant theta is actually equal to 5/3. We don't have an inverse secant button, but we do have an inverse cosine button. So if I know that the secant is equal to 5/3, I know that the cosine is equal to 3/5. So now I can do the cosine inverse of both of these. Cosine inverse and cosine are going to cancel, and I get my reference theta. It is actually equal to the cosine inverse of 3/5, which is 53.13. I want to have a visual idea of what this looks like. I'm looking at the cosine being positive, so that means that the x values are positive, which means that my triangles look like this, and this reference angle is 53.13. Now the first one is the one here in green now. Well, that angle actually is 53.13, so this happens to be one of my angles. Okay, so if you notice an angle that's in the first quadrant that's a reference angle actually ends up being what that angle is. But the second one is way over here. There's a horrible circle, but it's way over here. It's almost all the way around. It's 360 minus that 53.13, so 360 minus 53.13, which is 306.87. That's going to be my second theta. I'm just going to write it this way because that was the way that we had the first one written as well. Okay, so I end up with those two angles being the reference angles that happen. Now, if you're going through and you're solving and you end up with a number that comes out to be bigger than 1 with a sine and cosine, you can't have numbers that are bigger than 1 with sines and cosines. So your calculator possibly can come back with it with a no solution problem, and that's okay. Okay, we can have no solutions here. We're solving equations. We've always been able to have no solutions, so that can happen too. If you're getting a lot of no solutions, then you're probably doing something wrong, and you want to check on that. But if you end up with 1 or 2 here or there, you're probably doing just fine. This section takes you back a little bit more to algebra. So make sure you're working through the problems, but once you find the pattern, then you are going to be pretty set for how this all goes.